Good morning, class. I wanted to post another video for this week's modules, walking you through the expectations as well as the flow of both Module 1 and Module 2. Welcome all to Week 5 of eSchool. In this week, we have two modules to complete, working through W.2. Alright, so let's go ahead and get started. You're going to click on your initial class that you'd like to visit. You are then going to go, I've created two new assignments here. Week 5 Module 1 and Week 5 Module 2. Alright, to view these, let's go to Classwork, and you'll notice that there's a new topic outlined here. W.2, Models for Pitch and Volume. Okay, so in W.1 we talked about our generic model for sound. Okay, how sound transfers from one object to another, but now we're going to talk about two characteristics of sound, both pitch and volume. So you are all aware of when you listen to music, certain things are more high-pitched or low-pitched, deeper or higher, or it's louder or softer. Both of these have to do with the sound wave itself, and you can change characteristics of that sound wave to affect both the pitch and the volume. All right, so let's go ahead and walk through Module 1. Okay, when you open up Module 1, you're going to have two documents here. You're going to have a copy of the Week 5 digital worksheet for Module 1, as well as an editable modified Week 5 digital worksheet. You may choose which one of these you want to work on. Now, the modified digital worksheet will have some sentence stems, some helpful hints. It just has some more supports if you feel like you need them. Now, if you're going to work through the modified Week 5 digital worksheet, you're going to click on it. Once it opens up, you need to make a copy. So File, make a copy, and name this your last name. So for me, it would be Hensley, W.2, Models for Pitch and Volume. Click OK, and now you have a copy of it made. Once you have that copy made, you edit it just like a normal one and turn it in to Google Classroom. All right? Cool. Let's go back and look at our digital worksheet to walk through it. Okay? Each of you are produced with a copy of this so that you can edit it and turn it in as we've done in the prior lessons. Our objectives for Module 1 are students will be able to determine the relationship between pitch and frequency. Students will be able to understand the properties of sound and how they affect pitch and volume. Students will be able to create another model that can be used to represent sound. Okay? We've added in the past couple weeks this agenda here, where you're going to spend 10 minutes on the do now, which is our initial ideas. So remember, there are no wrong answers and hence no answer key. 15 minutes on experiment 1, 10 on experiment 2, 10 on experiment 3, and 5 on the mastery check, which will be linked into Edulastic. So let's walk through the flow of this lesson. The first 10 minutes, you're going to spend going through and sharing your initial ideas on this topic. Okay? You've got 1, 2, 3 questions. Okay? Once you've completed this, once again, there's no answer key here because at this point, all right, this is our initial ideas, and there are no wrong answers. Following your do now, you are then going to move on and spend 15 to 20 minutes working through experiment 1, talking about what is the relationship between pitch and frequency. All right. Follow the steps below to complete experiment 1. There is no direct instruction video since the setup of this module is just like last week. If you would like support on how to run through a module like this, check out last week's direct instruction video. So there's a link to last week's video here. All right, so if you click on this, it'll send you to last week's video if you get stuck on how to flow through these experiments. Okay? Step 1 asks you to go to a link. A page will then open that includes a play button and a box that displays the frequency in hertz. Okay? To do this, as the frequency increases, you're going to note something about the pitch of the sound as you hear. So as the frequency increases, what do you notice about the pitch of the sound? Okay? After that, you're going to run through this online tone generator again. Click on the stop button when you can no longer hear the sound. You are then going to ask your instructor what their maximum frequency of hearing is. Repeat this step for anyone willing that is in your house right now, if you would like to do that, okay? So you're going to fill out this with insert your name here. So if I was doing this, I would put my name. I would click on this tone generator. Once we click on it, let's go ahead and click on this. All right. This tone generator here is what you're looking for. Okay, you're going to press play, and as it goes up in hertz, you're going to notice a change in that sound. As that sound changes, eventually you're going to be able to stop hearing it. Once you can't hear it anymore, you're going to click stop and record this number here in your digital worksheet here. After that, you would Teams me and say, hey, Mr. Hensley, what was your hertz, so you can input it here. Okay. This is an effort for you to make sure you're reaching out to your teacher, so make sure you reach out and ask me what my maximum hertz was. All right. After that, you're going to move on to step 3, where you work through a graph and filling in these questions here. After step 4, there's a quick video to learn a little bit more about frequency, all right, where there's a definition down here. Okay. Step 5 is going to ask you to fill in the blanks based on this video you worked in step 4. Guys, at this point, you're at a good stopping point, okay? So if you are completing this synchronously during our science block, you may stop here and wait for the next class on Wednesday, okay? On Wednesday, when we come back, you are all going to be working through experiment 2 about what properties of sound affect the pitch, okay? You're going to go to this PhET simulation, which if you click the link is going to bring you to a sound PhET sim, okay? You then are going to download or press play here to play with the simulation. While you play with that simulation, you're going to select the tab Listen to a Single Source. So that tab is going to look like this. Using the controls on the right, check the audio that audio is enabled and select the speaker. Set the amplitude to a maximum, far right of the slider. Okay, there's a little infographic here to show you how to do that. So you can adjust the frequency and the amplitude of the wave. Okay, well, remember, frequency is how often the waves occur, and amplitude is how big the waves are vertically. Okay. After step 2, you move on to step 3, where you answer a few questions before moving on to step 4. Okay. Step 4, we're introducing you all to a new term called wavelength. All right. Wavelength is represented by the distance between two peaks or two troughs of a wave. In this density graph here, it's the distance between the two darker regions. Okay, that's what we call the wavelength. Okay, after you answer this question regarding the wavelength, you move on to step 5, where again it asks you to play around with this PhET simulation and answer the questions therein. All right. Finally, you move on to step 6, where it says complete the statements below about amplitude, volume, and particle density. All right. At this point, you've completed experiment 2, and you can go ahead and check your answers here using this link here. Okay. Remember to check your answers after each assignment to make sure you're on the right track and allow you to move forward before the mastery check and check all your work. Okay. Experiment 3, again, should take about 10 minutes, where we're investigating what is another model that can be used to represent sound. Okay. You're going to follow the steps below to complete experiment 3. All right. Step 1, the image below includes a density diagram and a graph axis with dashed lines for particle density. On the dashed lines of the graph axis, draw a dot for each area of the particle diagram directly below the letter on the density diagram. The first data points are graphed for you as an example. Then connect the points. All right. So A, we're talking about particle density, so it has a maximum particle density at A. At B, you can see that there's a lot of particles, but it's not as dense as A, so you're going to say that's medium. At C, that's a minimum particle density, okay? After that, if we go to D, okay, you'll notice that it's back to a medium, and E, it's back to a maximum, okay? As you draw this, you'll start to see a shape form. I want you to pay close attention to that shape and what it means about waves, okay? Now, remember, to edit a diagram, you click on the diagram, click edit, and then you go into here and you'll be able to draw little circles, all right, where you would like that diagram or that point to be. Okay? After that, you hit save and close, and that diagram will be back uploaded here with your completed diagram. Okay? Don't forget to connect the points. You should not have dots. You should have a connected point wave. Okay? All right, step 2. The graph of a particle density versus distance that you drew in step 1 is called a wave diagram. Density diagrams and wave diagrams are different representations of sound waves. So whatever we drew up here in this particle density graph is going to be the same as this, just a different take on it, okay? Now, after that, okay, you're going to go through this particle density or wave diagram again, following along with these particle densities here, okay? You're going to do that a couple times as practice before moving on and checking your answers using this link here. All right, guys, don't forget how to draw here, okay? If you click here and click edit, you can scribble, all right, by clicking select line and scribble. By doing that, you'll be able to draw a kind of wave function that looks something like this, and then hit save and close, okay? Once you're done with experiment 3 and you've walked through experiments 1, 2, and 3, you then want to make sure you've checked all your answers, looked at the key points of the lesson before moving on to this module's mastery check in Edulastic, which is titled this here. All right, guys, this is all we got for Module 1. We're going to spend Monday and Wednesday working on Module 1, and hopefully Thursday working on Module 2. Okay, let's go ahead and take a look at Module 2 before I let you guys go. All right, now that we are back in our classwork section of our Google Classroom, we can click on Module 2. Again, you'll have 2 digital worksheets. One is modified, and one is a copy of Week 5 digital worksheet, the normal one, okay? The modified work here, okay, is up for your grab if you want it. If you would like to work on that, you may. If you want to work on the other one, you may do that as well. Only turn in one of them, however. Remember, if you work in the modified environment, make sure you make a copy and rename it with your last name, digital worksheet, so I know which one is yours. All right? So let's take a look at this digital worksheet here. All right? This is Module 2, okay, which if you remember from last week, you're going to be working through this pretty much on your own, okay? And there's not going to be many experiments. This is going to be scientist ideas reading, consensus building with a formative at the end. The objective for this unit is students will be able to understand how models of sound can account for the sound with different pitches and sounds with different volumes. The agenda, you're going to do a do now for 10 minutes, a 15-minute read to learn, a 10-minute partner practice similar to last week, and a 15-minute formative assessment. All right. You want to click on this link for a quick note about this module before you get started. As you work through these do now, make sure you're spending about 10 minutes on it and make sure you check your work once you're done. After that, you're going to spend 20 minutes with a read to learn about W1 model for sound, a read to learn. So make sure you follow this scientist ideas reading. If you click here, you can click and it'll open up the scientist ideas reading that we are familiar with from the past, okay? It's going to look something like this. As you're working through and reading that, you're going to take notes, summarizing the meaning of different words, answering a couple of questions where you can insert drawings as you want, okay? You're also going to make sure you define the wave crest and the wave diagram implies about particle density, all right? And answer all the questions as you close read this document. I think it would be helpful, guys, to have both open at the same time where you can split your window so you have the scientist ideas reading here and this Google Classroom document here. That way you'll be able to work on both and input this as you read along. All right? Make sure you've checked your answers before moving on. Okay? Step 10 here, partner practice, is going to be similar to last week. Okay? You're going to find your partner. The partners are going to be the same as last week, so you can see that document from last week, which I will also link into the Google Classroom as well. And you're going to work together, if you are both online, using the density diagram and wave diagram shown below. Rank the pitch and the volume of each. All right, for example, x equals y, but y is greater than z. Okay, couple of quick notes here about these greater than and equal to signs. If it opens this way, it means a is greater than b. If it opened the other way, it meant b is greater than a. All right. Once you complete partner practice, you all, make sure you review your vocab words, your key points, and make sure you've checked all your answers up to this point before working on the formative assessment in Edulastic. All right, Guys, all this work is going to be due on Friday at noon. I hope this helped, and thank you all for listening.